It takes about 500 years to build a full-blown civilization, from scattered settlements to written language, bureaucracy, social stratification, metallurgy, and monumental architecture. That's not a guess, it's a pattern. Take Mesopotamia, for example. From the first signs of organized agriculture in the Fertile Crescent around 9000 BCE, it took just a few millennia for Sumerians to construct Uruk, one of the first true cities, with ziggurats, cuneiform writing, and a social hierarchy fully in place by 3200 BCE. Similar timelines emerge in Mesoamerica, Egypt, the Indus Valley, and the Yellow River Basin. A 2010 comparative study in Science showed that regardless of geography, the rise of complex societies tends to follow similar demographic and agricultural thresholds, especially once surpluses and intergroup competition emerge. In 2014, another paper in Nature used radiocarbon dating and settlement size modeling to show that once farming communities hit a critical population density, social complexity can merge astonishingly fast, even in places with no external influence. In other words, civilization doesn't need divine intervention, it needs calories, crowding, and time. This brings us to a chilling realization. Homo sapiens have been around for at least 200,000 years, and we had the same anatomy, the same brain volume, and the same potential. If it only takes around 500 years to go from tents to temples, what were we doing for the other 196,500? We like to think we know, but most of that time is archaeologically silent. And here's the thing about silence. It isn't the same as absence. The Earth is not a neutral archive, it's an active, eroding, subducting, weathering volcanic, ocean-rising machine. Only a fraction of human history survives in the form of durable artifacts. And of those, only a fraction are ever found. A 2022 review in Nature Ecology and Evolution made it explicit that when it comes to early human archaeological data, preservation bias and geographical gaps make it almost impossible to rule out earlier waves of cultural complexity that have since disappeared. We could be missing entire cycles. It wouldn't be the first time. The late Bronze Age collapse around 1200 BCE wiped out nearly every major Mediterranean power as writing systems vanished, cities burned, and trade collapsed. It took centuries to recover, and that's with surviving stone inscriptions. So, what happens if a civilization rises in a coastal floodplain, gets erased by volcanic activity, or buried under a glacier, and never even reaches metallurgy? It disappears, not metaphorically, but literally. The assumption that we are the first civilization isn't based on evidence, it's based on a lack of evidence, and that's not the same thing. What if we never were the first? The past isn't preserved, it's filtered. What we know about prehistory comes from accidents like bones that landed in just the right soil, pigments sheltered in just the right cave, or tools abandoned in just the right sediment, while everything else is eaten by time. Most of Earth's surface is geologically active. As coastlines submerge, forests overgrow, deserts scar, and plates shift. For most of their existence, humans have lived in places least favorable to preservation, such as riverbanks, floodplains, and coastlines, the kinds where civilization might thrive and vanish without a trace. According to a study by Cooper and Stringer published in 2013 in Science Advances, the fossil record of Homo sapiens is sporadic and unevenly distributed, particularly in equatorial regions, where high temperatures and humidity destroy organic material within decades. In other words, we know far less about human life in Africa, South Asia, and island Southeast Asia than in cold, dry, archaeologist-friendly Europe. Even within Europe, absence in the archaeological record doesn't always mean cultural inactivity. A 2020 study in Nature Communications modeled data loss over time and concluded that less than 1% of the stone tools or symbolic artifacts likely made by Paleolithic humans have survived in a context we can still detect. Now, extrapolate that loss to any organic or perishable materials like wooden buildings, fiber clothing, paper scrolls, or primitive circuitry. Even modern concrete, left unmaintained, breaks apart within a few thousand years. In a landmark 2018 study published in Anthropocene, researchers investigated how long an industrial civilization like ours would leave detectable traces in the geological record. The answer is a few thin layers of anomalous sediments. Plastic, carbon isotopes, and rare earth metals may be recognizable to future scientists, but they would be invisible without specific tools. Now take away the plastic and the electronics and assume a civilization built from clay, fiber, pigment, and wood. Now bury it under volcanic ash or let it rot beneath a jungle canopy. What's left? Not much, and certainly not enough for certainty. Even when we do find traces like the 500,000-year-old shell engravings in Java discovered by Jordans and published in Nature in 2015. We often debate whether they count as symbolic because they don't fit our preconceived timelines. That's the danger of a silence-based model. We assume that what we haven't found never existed, but silence can be caused by decay, erasure, or blindness, just as easily as by absence. Worse still, our methods are slow. Archaeologists estimate that only a fraction of the Earth's surface, less than 1%, has been systematically surveyed for prehistoric sites. And even less has been surveyed using high-resolution techniques like ground-penetrating radar or magnetometry. In 2021, using LIDAR technology, which stands for light detection and ranging, a remote sensing technology that uses laser pulses to measure distances and generate precise three-dimensional maps of surface structures. Praekunmer's team revealed over 150 monumental structures in the Amazon, previously invisible beneath the canopy. Some date back more than 2,000 years, and were completely unknown until now, and those are relatively recent. So imagine what else might be buried. Imagine what may have existed 100,000 years ago during one of the many warm, interglacial periods, flourishing and vanishing under rising seas or volcanic winters. The problem isn't just what we've missed. It's what we've mistaken for nothing. We treat Earth like a museum, but it's more like a chalkboard, constantly wiped clean. What doesn't get preserved gets forgotten. When we picture prehistoric humanity, we often imagine a slow crawl toward complexity, with millennia of monotonous survival punctuated by a sudden burst of creativity around 50,000 years ago. But that picture might just be wrong. The explosion of symbolic behavior was never a singular event. It was a tipping point, one that came after hundreds of thousands of years of cognitive preparation, false starts, and forgotten attempts at meaning-making. The first signs didn't appear in France or Spain. They showed up in places like Blombos Cave, South Africa, where archaeologists uncovered engraved art plaques, dating to 100,000 years that are abstract, deliberate, and deeply human. Alongside them were perforated shell beads and tools treated with heat to improve their performance, and early use of pyrotechnology requiring planning and control. These aren't survival items, they're symbolic, decorative, and cultural. Further north, at Pinnacle Point, excavations revealed Homo sapiens using fire to systematically process stone tools and consuming shellfish, signs of ignition and environmental mastery dating back 164,000 years. These are behaviors that require not just intelligence, but social transmission, teaching, memory, and a value system. In 2015, Nature published a study showing engraved zigzag patterns on a freshwater shell from Java made by Homo erectus around 500,000 years ago. The engraving was methodical and premeditated, not random scratching, but design, and it came from Homo erectus, who had a brain smaller than ours. It showed that symbolic thought, mark-making, and abstract representation didn't originate with us. It flickered across hominin species long before Homo sapiens became dominant. It wasn't unique, it was shared. Neanderthals, once cast as brutish cave dwellers, are now known to have made composite tools, controlled fire, buried their dead, and, most strikingly, created cave art in Spain over 6,000 years ago, confirmed by uranium, thorium dating. That's around 10,000 to 15,000 years before Homo sapiens arrived in Europe. The Bruniqual cave structures, also Neanderthal-made, date back a staggering 176,000 years, deep inside the earth in total darkness. This was not survival behavior, it was ritual, or at least intention. Even Homo naledi, with its small brain and primitive frame, may have deliberately deposited bodies in concealed cave chambers over 200,000 years ago. It's controversial, but the implications are seismic, as burial means memory and meaning, perhaps even belief. So, why didn't these sparks lead to an inferno? Why didn't civilization ignite then? Because fire needs fuel. Symbolic behavior can emerge in isolated groups, but for it to last and evolve, it needs continuity. That means large, stable populations, high-fidelity transmission of knowledge, and redundancy. If a single artisan dies before teaching another, the technique dies too. That's not failure, it's fragility. Most early human populations were tiny and scattered, and genetic evidence suggests bottlenecks severe as 1,000 to 10,000 breeding individuals globally at several points in our timeline. That's fewer people than a high school gym. Under those conditions, culture isn't inevitable, it's volatile. The early symbolic acts we found, like beads, pigments, and carvings, may not be the first of their kind. They may simply be the rare ones that got lucky, survived erosion, and were found before they decayed. Others may have burned out, unrecorded and unremembered. The long silence isn't a void. It's a graveyard of forgotten flames, which means the first civilization may not have failed to rise. It may simply have failed to endure. We treat civilization like it's the endgame of intelligence, as if once a species can think symbolically and control fire, pyramids, and parliaments are only a matter of time. But that's not how evolution or history works. Civilization isn't the guaranteed next step. It's a razor-thin convergence of cognition, ecology, and luck. For every Egypt or Sumer, there may have been dozens of groups, just as cognitively advanced, who never made it past the threshold due to drought, disease migration, or the simple mathematics being too few for too long. In 2018, a major synthesis in science advances explored why large-scale societies emerged in some regions, but not others. The study found that while symbolic behavior and social complexity are widespread among humans, the leap to institutionalized civilization with bureaucracy, monuments, and urban planning requires delicate precision, pre-energy surplus, usually tied to intensive agriculture. Even then, geography matters. Civilizations emerge most reliably in ecotones, regions where diverse biomes intersect, providing ecological buffering and trade opportunities. That means civilization isn't just about brains. It's about rivers, floodplains, seasonal cycles, domesticable grains, and animal herding. Jared Diamond famously argued in Guns, Germs and Steel that Eurasia's east-west axis gave it a decisive head start, allowing crops and innovations to spread across similar climates. But even that didn't guarantee success. The Harappans built cities with grid, planned streets and drainage systems by 2600 BCE, then abandoned them within centuries, likely due to climate shifts documented. Nature science equals. Then there's Göbekli Tepe, discovered in southeastern Turkey in the 1990s. Göbekli Tepe dates back over 11,000 years, before the advent of agriculture and writing, before metallurgy. Yet, it contains T-shaped limestone pillars weighing up to 20 tons, arranged in circular temples carved with foxes, vultures, and headless men. These weren't made by farmers but by foragers. According to a 2020 study in PS, the scale and complexity of the site suggest advanced planning, labor coordination, and shared symbolic frameworks. Not only does Göbekli Tepe predate cities, it flips the script entirely. It may have preceded the very agriculture that supposedly made such structures possible, which implies something uncomfortable. Civilization may not be the endpoint of symbolic thought. It may be a detour, a side effect of ritual and memory, gathering enough critical mass to push people to settle. Not the other way around. And yet, Göbekli Tepe was buried by its own builders on purpose. Whether for preservation, ritual closure, or reasons we'll never know, the site was backfilled within a few centuries and forgotten. How many others like it once stood and disappeared? The Sahara wasn't always a desert. Between 10,000 and 5,000 years ago, it was a green corridor filled with lakes, grasslands, and human settlements. Satellite imaging has revealed buried structures and riverbeds, now hidden under meters of sand. A 2021 Nature Communications paper noted that climatic pulses repeatedly greened and then dried the region, forcing groups to migrate or collapse before urbanization could take hold. Even sea level rise, driven by the end of the last ice age, swallowed tens of millions of square kilometers of habitable coastline, precisely the kind of stable, rich environments where early humans liked to cluster. That includes much of what is now the continental shelf. According to quaternary science reviews, over 70% of archaeological sites older than 10,000 years may be underwater. We don't see a pattern of inevitable ascent. We see a pattern of precarity, of cultures sprouting and staggering and stalling, of complexity that flashes briefly, then vanishes beneath flood, fire, or forgetting. Civilization didn't happen because it was destined. It happened because, against all odds, it didn't fall apart first. When conditions align with stable food sources, a rising population, and sustained knowledge transfer, complex societies ignite fast, sometimes frighteningly fast. In Mesopotamia, it took less than 1,000 years to go from irrigation ditches to cuneiform writing and centralized temples. In Mesoamerica, the Olmec built colossal heads and planned cities within a few centuries of forming sedentary communities. The early Maya, the Norte Chico of Peru, and the Yangshao of China all show similar trajectories once demographic and environmental tipping points are crossed and social complexity accelerates. A 2009 paper in Science by Powell, Shannon and Thomas tested this mathematically using agent-based simulations. They showed that the retention and elaboration of complex cultural traits, like symbolic tools or ritual architecture, depend not just on intelligence but on population density and intergroup connectivity. Once enough individuals are close enough, long-lived enough, and communicating frequently enough, ideas stop dying with their inventors and start snowball. This creates a dangerous thought experiment. If it only takes a few thousand years to build a city from scratch, and Homo sapiens have been anatomically modern for over 200,000 years, how many times could we have done it before? The window is huge and the fuse is short. Even Homo erectus, a more primitive hominin, lasted nearly 2 million years. If they had cultural potential, and the evidence from Java's shell engravings and complex tool use suggests they did, then their timeline offered 500 times the time to reach our level of complexity. They just never hit the demographic ignition point. Population in deep time is both the flint and the fuel. In a 2013 Nature paper, researchers used mitochondrial DNA to reconstruct human population history and found repeated bottlenecks over the past 150,000 years, including one where the breeding population may have dropped below 2,000 individuals globally. That's extinction level small. No matter how intelligent or inventive those humans were, their chances of sustaining cultural memory across generations were near zero. That's why symbolic innovations flare up and disappear from the record. Why we see red ochre in Blombos, then nothing for tens of thousands of years. A group may have invented body paint, personal ornamentation, or even crude musical instruments, but unless they lived long enough and passed it on effectively, the behavior vanished like smoke. Cultural drift is the default. Memory is fragile, and civilization isn't a given. It's a race against forgetting. This is why the sudden creative burst around 50,000 years ago might not be sudden at all. It might be the moment Homo sapiens finally crossed a critical mass threshold. With enough humans in enough clusters, and with enough connectivity to hold on to their fire. It was a social tipping point, not a neurological one. The analogy is modern early symbolic behaviors were like beta versions of an app, innovative, but unsupported. They crashed easily and disappeared on Logot. But once enough users were online and connected, the system stabilized, culture became scalable, and ideas could be stored, modified, and distributed. That's when complexity took off. So, what happens if that population collapses again? You lose everything. Civilization is fragile, not just in prehistory, but always. In the public imagination, collapse is rare, a dramatic exception, like the fall of Rome or the sinking of Atlantis. But when viewed across deep time, collapse isn't the outlier. It's the baseline. The norm stability is the anomaly. Every known ancient civilization has collapsed, some slowly, some violently, but none were permanently immune. Egypt, Sumer, the Maya, the Harappans, the Hittites, Angkor, Teotihuacan. The only difference is what came after. In 2012, a study in PNAS identified over 24 known rapid societal collapses tied directly to climate variability, droughts, or volcanic activity. Over the Holocene, all happen in advanced, literate, and organized communities, and they still broke. Now, stretch the timeline around 74,000 years ago. The Toba supereruption in present-day Indonesia injected an estimated 800 cubic kilometers of ash and gas into the atmosphere. That's 17 to 18 times stronger than the eruption of Mount Tambora in 1815 that caused the volcanic winter that followed and the fall of entire regimes in Europe. Toba triggered a volcanic winter as well, but a much harsher one. Ice core data from Greenland and Antarctica confirm a sharp drop in global temperatures, up to 10 degrees Celsius in some regions. The eruption left layers of glass shards across South Asia, and its ecological effects would have devastated plant and animal life for years. Genetic studies suggest the aftermath narrowed the effective human breeding population to as few as 3,000, 10 to 10,000 individuals globally, not enough to sustain trade, memory, or knowledge across continents. Any nascent civilization or even symbolic tradition would have been extinguished like a candle in a hurricane. Toba wasn't alone in this prehistoric world. The climate chaos of the Younger Dryas, from 12,900 to 11,700 years ago, possibly linked to a massive meltwater pulse, or even an extraterrestrial impact, triggered megafauna extinctions and forced human groups into drastic adaptations. According to a 2010 study in Science, rapid cooling in the North Atlantic disrupted weather systems across the globe, drying the Middle East and altering migration patterns. In North America and Eurasia, in 536 CE, another volcanic winter probably triggered by a massive Icelandic eruption, cast a veil of ash and sulfur across the planet. Contemporary accounts describe a sun that gave no light for 18 months. Tree ring data show the coldest decade in 2,000 years as crops failed, plagues spread, and civilizations reeled. A 2018 paper in Antiquity describes it as the beginning of the late antique Little Ice Age, a multi-century disruption that transformed Eurasia's cultural and political landscape. Even recent history shows how little it takes. In the 1990s, the collapse of the Soviet Union led to a sudden drop in life expectancy, GDP, and institutional stability across vast regions. Between 1991 and 1994, male life expectancy in Russia fell by nearly 7 years, a mortality shock comparable to a wartime event, as reported in The Lancet in 1998. This wasn't caused by an invasion or a natural disaster, but by the abrupt unraveling of state infrastructure, economic systems, food distribution, public health, and trust. That was a nuclear superpower with global ties and digitized archives. Now, imagine a pre-modern society facing the same kind of systems failure without printing presses, telecommunications, or antibiotics. What we call collapse can unfold in months, with knowledge gone in a generation, technology irreproducible, and language unrecoverable, not because it wasn't brilliant, but because it wasn't copied. Civilization is not a castle, it's a sand sculpture at low tide. Climate is only one threat. Disease can erase memory just as quickly. The Black Death killed up to 60% of Europe's population in the 14th century and shattered institutions from Florence to Beijing. Smallpox wiped out entire civilizations in the Americas before Europeans even made contact with their core cities. And those were literate, densely populated societies. Oral traditions are even more vulnerable now. Consider a hypothetical. Say an early Homo sapiens population somewhere along a now submerged coastline, rich in fish and stable in climate, begins building shrines, settles, invents counting, and crafts rituals. But the sea rises, or the earth shakes, or a virus jumps from a bat. What survives? Not the fiber mats, not the wood carvings, and not the coastal enclosures now 50 meters underwater. Just a blank spot, a silence. And with each silence, the clock resets. Humanity has to rebuild, rerun the experiments, and retest the limits of language, structure, cooperation, and meaning. Not because we forgot how to think, but because catastrophe is the rule. When memory burns, there's nothing left but ash. The most haunting evidence for lost civilizations isn't what we find. It's what we nearly missed. For centuries, archaeology relied on surface visibility and chance of pottery shard, a buried wall, a local legend pointing to ruins. But now, with satellite imaging, LiDAR, and deep penetrating radar, we're seeing through forest canopies and meters of sediment. And what we're finding suggests the human past is far deeper and more crowded than we ever imagined. We've talked earlier about discoveries in the Bolivian Amazon dating back over 2,000 years, but this is just one region. Similar work in Cambodia has uncovered vast hydraulic systems connected to the Khmer Empire, suggesting that what we once thought were isolated temples, like Angkor Wat, were actually part of a vast urban complex, a sprawling, low-density metropolis hidden by trees and time. In Saudi Arabia, aerial surveys in the deserts have revealed over 1,000 mastodons, stone enclosures some over 7,000 years old, whose purpose remains unknown. They're not graves nor corals, but they suggest ceremonial behavior on a scale we didn't expect in such an arid early setting. Then there's what lies beneath the sea. Global sea levels have risen over 120 meters since the end of the last ice age, enough to swallow entire coastlines where early humans would logically cluster due to stable temperatures, food access, and fresh water. According to a 2021 paper in Quaternary Science Reviews, as much as 20 million square kilometers of once inhabited land is now submerged, and yet less than 5% of continental shelf zones have been surveyed archaeologically. When we do look, the results are immediate. In the Doggerland region of the North Sea, a landmass that once connected Britain to continental Europe, sonar has revealed stone tools and even traces of mammoth butchery sites, a drowned world of Paleolithic life lost to water. In the Mediterranean, off the coast of Israel, researchers found a submerged Neolithic village at Atlit, Yam, complete with stone houses, burial areas, and a ritual stone circle. It was likely wiped out by a tsunami triggered by a landslide near Mount Etna around 8,000 years ago. All of this suggests a chilling possibility. What if the missing civilizations we've speculated about, the ones whose absence makes us assume we're the first, were simply misplaced by time, not erased by aliens or lost in some Plato-fueled myth, but drowned in meltwater, buried in sediment, or concealed under jungle? What if the ruins of a 70,000-year-old symbolic culture lie beneath the Bay of Bengal or 50 meters below the Arafura Sea between Australia and Papua? We tend to scoff at flood myths, but nearly every ancient culture has one, maybe for a good reason. The Sumerians told of Zeusudra. The Akkadians had Atrahasis. The Bible has Noah. India tells of Manu. The Greeks spoke of Deucalion. And the Muisca of Colombia and the Yoruba of West Africa have their own versions. These aren't carbon copies, but they all echo the same fear: a world wiped clean, a memory drown. Maybe they're inherited trauma, a distorted echo of real floods, real losses, real resets. The earth is filled with these absences, civilizations that flickered into being, burned briefly, and were buried by very planet that nurtured them. We weren't the only humans to try building something lasting. We are just the only ones still walking above the dirt. We don't know that's the honest answer, not because the evidence points to no, but because the silence doesn't let us say yes. We walk on a planet that erases, that buries, that forgets, and we assume too much from what remains. We can't assume anything from what did not leave any traces. But here's what we can say. If a civilization had emerged 100,000 years ago on a tropical coast, rich with life, far from tectonic stability, and collapsed 95,000 years ago, we would almost certainly never know. It would leave no steel, no plastic, no satellites. If it used fiber, wood, ceramics, and organic compounds, and if it never reached fossil fuels or metallurgy, then after tens of thousands of years, every structure would be dust, every book pulp, every map myth, and every archive ash. In 2018, researchers in Anthropocene asked what traces modern industrial society would leave in the geological record. The answer is maybe a few centimeters of synthetic residues, plastics, nitrogen spikes, and isotopic anomalies. That's us, with nuclear reactors and global shipping lanes. Now, subtract all that, what remains? A-shaped stone, a strange alignment, an unexplained layer of charcoal. We don't even have full skeletal fossils for many human ancestors who lived only 50,000 years ago. If a civilization rose and fell in that span, why we expect skyscrapers? The question isn't where are the ruins? It's why would there be any? In science, the absence of evidence is not evidence of absence, especially when preservation bias, geological recycling, and underwater burial eliminate most of the planet's memory by default. This doesn't mean ancient humans had high technology or built megacities. It means they were capable, and under the right conditions of population density, climatic stability, and surplus energy, they could have crossed the threshold, and maybe they did. The idea that we are the first to imagine gods, to bury the dead with meaning, to tell stories around a fire, and to build stone upon stone is flattering but likely untrue. because the timeline is long, the materials are fragile, and the filter is brutal. We may be the first to broadcast our thoughts to satellites, but not the first to feel wonder, not the first to draw myths in pigment, not the first to mourn, or plan, or dream. We are just the first to build past the tipping point of memory. And even that is tenuous, because we now face the same fragility that ended all the others: climate, instability, overreach, ecosystem collapse, pandemics, and nuclear risk. We are not guaranteed to be remembered either. The idea that we are the ones history will always remember assumes there will be someone left to read. So maybe the real question isn't, were we the first? Maybe it's, how long will we be visible after we're gone? The ruins we might leave won't be in stone. There'll be chemical signatures, satellite carcasses, and garbage on the seafloor. That's our fossil layer, our sediment story. But before we vanish, if we vanish, maybe we should ask, what kind of ancestors do we want to be? Because yes, we're probably not going to be the last, not to aliens, not to time travelers, but to the next ones, whoever they are, whenever they come. If we're not the first and we're not the last, then we're just another middle chapter, and we owe it to both sides to be legible. If this video shifted how you think about our place in time, if it made the silence feel a little heavier, or the ground beneath your feet a little more mysterious, don't let it end here. Subscribe to the channel for more stories from deep history and buried memory. Like the video if it lit a spark. Share it with someone who's ever looked at the horizon and wondered what used to be there. And drop a comment. Who do you think we missed? What kind of people might have come before us and left without a trace? Your curiosity helps these stories echo further. Every click, every thought keeps the fire alive. Thanks for being part of that. Until next time, keep listening to the echoes.